Welcome back, students. Hope you joined the last lesson. If you have not joined it, you have to go and join it. You have to go and watch that one before this, else you'll not understand what we are coming to do today. So we are studying bearings now, and then we've spoken about bearings and we've looked at all the tricks on bearings. Today we are looking at questions relating to distance bearing, right? And then so let's go straight to the board and look at this question and solve it. After we'll see who can solve another question. Then I'll give you questions to try yourself. So let's read a question together. Now the question says the bearing of P from R is 300 degrees, and then the bearing of P and the bearing of Q from P is 030 degrees. It's the same as 30 degrees, but in bearings we don't put it in two-dimensional. So when it's 2, we just add 0 to it. Now if the distance between P and Q is 5 kilometers and the distance between P and R is 6 kilometers, now calculate A, the distance between Q and R, correct to 3 significant figures. B, the bearing of Q from R, correct to the nearest degree. Alright, so if you have been following the class for a while now on bearing, you realize that before you will be able to solve a bearing question like this, then you first need to get an accurate diagram. Without the diagram, you cannot solve it very well. So let's all draw the diagram together, then after we'll look at how we can solve this particular question. So the question says the bearing of P from R is 300 degrees. So let's first draw a 300 degree bearing. So drawing from here, we all know on the Cartesian plane, these are 90 degrees, plus 90, that will be 182.7. So 300 will be somewhere here, right? 300 falls in the fourth quadrant, okay? And then, of course, for me to know or have an idea of how the angle will be, whether it will be bigger or small, this quadrant is 90. Let me subtract 720 from 300, that will give me 30, right? So which means that my line will be somewhere here, because of course 30 must be smaller than 60. The whole thing is 90. So wherever I'll end, I draw another Cartesian plane there. So this one is 30 degrees. And the bearing started from the bearing of P. So the bearing started from R. So it started from R, which means from the north up to this line is 300 degrees, right? So this is P. And then they went on to say that, and the bearing of Q from P is 30 degrees. So aside from here, aside from this bearing, there's another bearing of 30 degrees. But this time it started from where? P, right? So we draw a bearing of 30 degrees from P. Bearing always starts from the north, right? So we draw 30 degrees from the north of P, which is going to be somewhere here. Right? So we draw a bearing of 30 degrees. Of course, since this is 30 degrees, it's going to be 60 degrees because the whole quadrant is 90. 60 plus 30 will give you 90 degrees, right? And of course, since this one and this one are parallel lines, since this is 30, it's alternating to that, this also will 30. So wherever this one will end and this one will end, we join it like that, right? Alright, now they also told you that the distance between P and Q is 5 kilometers. The distance, that is Q, right? The distance between P and Q is what? 5 kilometers. And then the distance between P and R is what? 6 kilometers. That's why I made this one a bit shorter than this, because looking at the dimensions they've given, 5 is of course shorter than 6, right? Now the question is now asking us to find the distance between Q and R. So now we are finding the distance from Q and R. And of course, since we have a 90 degree here, then you should know that we can either apply Pythagoras Theorem or trick. So drawing the diagram, let me position the diagram well. Positioning the diagram well, I have something like this. This is my 90 degrees. I just tilted the diagram like this. So this is my R, this is my Q, and this is my P, right? Of course, this one is 5 kilometers, and this one is 6 kilometers. Now the question is demanding us to find the distance between Q and what? R. Of course, we have to apply Pythagoras Theorem here, right? And in Pythagoras Theorem, the line that faces the 90 degrees is always called the hypotenuse. And Pythagoras says what? Hypotenuse squared. So I have QR squared equals what? QP squared plus PR squared, right? Now looking at the question, we have QR squared equals, this is 5 kilometers, so 5 squared plus this is what, 6 squared. So I have QR squared is going to give me 5 squared is 25, 6 squared is 36. So I have QR squared is going to give me 25 plus 36 is going to give me 61, I think. Yeah, it's going to give me 61. So I have QR equals square root of 61, because of course I have to square root both of them because this one has a square. Right, so it means my QR square root of 61 I think is going to give me 7.81 kilometers. 7.81 kilometers, right? So we have found the distance of Q from R, right? That is the first solution they want us to give. They say 3 significant figures. Already this one is in 3 significant figures. Now the second question says we should find the bearing of Q from R. This time we are finding the bearing. You know, bearing always starts from the North Pole, right? Clockwise to whatever they are asking us to find. They say the bearing of Q from R. It means the bearing is starting from R. So we are finding from the north of R up to the Q line. So if you check the question. So the bearing of R from Q is from the north of R up to the Q line, right? But already you know this side, this is 90, this is also 90, making 180. This is also 90, making 270. And we have this one 30. So we just need this one to get a complete bearing. You get that? So the bearing, the actual question they want now, the bearing of Q from R is actually this 270 degrees plus this 30 degrees plus, let's label here theta, so plus theta, right? This one is going to give us 300, right? So we have 300 degrees plus theta. So we don't know this particular angle. Let's see if we can find it. Now, if you relate this one to this new diagram that I drew, you realize that this theta in question is here. Okay? This theta in question, drawing this triangle, this theta is here. Now, because we have 2 sides, we can use trigonometry to find this theta. And you know, in trigonometry, of course, this is hypotenuse. In trig, the line that faces the angle is my opposite, right? So it means if the angle was here, my opposite would have been down. We've done trig already, so if you have not watched that, kindly look for that video and then watch that. And then, of course, since this hypotenuse on this opposite, this one has no option than to be what? Adjacent. So we take the 2 given sides, right? So we have O and A. And of course, using the learning aid, so ka to A, you realize that which one of them contains the 2 given sides, O and A? That will be this, right? So we use this. So we have tan of the angle, tan theta, is twice opposite over adjacent. So my opposite is 5 and my adjacent is 6. Now if I want theta, theta is going to give me tan inverse of 5 on 6, right? And tan inverse of 5 on 6, it's going to give me 39.8 degrees, which is approximately equal to what? 40 degrees. Therefore, our theta gave us what? 40 degrees. Therefore, our bearing of Q from R is 300 plus what? 40 degrees. That will give us 340 degrees. So this is the solution to the problem. So the bearing of Q from R, the distance of Q from R is actually 7.81 kilometers. And then the bearing of Q from R is going to give us what? 340 kilometers. Alright, so let's look at another question. And then I'll give you more questions to solve. So let's look at the second question. Let's read it together. The second question says that a village P is 10 kilometers from a lorry station Q on a bearing of 0.65 degrees. Degrees. Then another village R is 8 kilometers from Q on a bearing of 155 degrees. They say calculate A, the distance of R from P to the nearest kilometers, and B, the bearing of R from P, right? So this one is quite similar to the first one we solved. So of course we have to get a diagram first before we can do whatever we can do. So let's draw the diagram together. They say a village P is 10 kilometers from a lorry station Q on a bearing of what? 65 or 065 degrees. So you all know that bearing always starts from the north, right? So 65 degrees is going to give me something like this. So that, and the bearing started from where? From the lorry station Q. So it started from Q. This is 65 degrees. Of course, if this is 65, then this one is going to be 25 degrees, right? Because the 2 is going to be, it's supposed to be 90. So it started from Q, so this one is P, okay? And then after that, they said the distance is 10 kilometers. Okay, so after that, they say another village R is 8 kilometers from Q. So this time the bearing started from where? Q. We are drawing another bearing from Q. The bearing is what? 155. So we are drawing 155 from Q. You know 155 will fall here. It will fall within 180. This is 90, this is 180, right? So it will fall within 180 degrees. So for me to draw a bearing of 155 from here up to here, somewhere here, you know, for me to know how the angle will be, whether it will be bigger or small, let me deduct the 90. If I deduct 90 from 155, I'm going to get 65. 65 is quite bigger. So let me draw the line somewhere here. Okay? And then, okay, this one is shorter than this, so let me explain. Because they said this one is 8 kilometers. Alright, so the whole thing is 155, but for me not to complicate stuff, let me just put 8 angle here, that is 65. Because 65 plus 90 will still give me 155, right? So wherever this one ended and wherever this one ended, I joined the two like that. This one was, is it R? This is R. Of course, we are getting a 90 degree here. You know, 25 plus 65 is going to give me 90 degrees, right? So since we have 90 degrees here, we can still apply trigonometry or what? Pythagoras Theorem. Any of them is going to work. The question says find the distance of R from P. So we are finding the distance of R from P. So of course, let me redraw the diagram, reposition the diagram so you can see it clearly. If I reposition the diagram like that, tilting the diagram this way, this becomes my R, this becomes my P, and this becomes my Q. This is my 90 degrees. So my QB is going to give me 10 kilometers, and then my QR is going to give me 8 kilometers, right? Okay, now I now want the distance of PR. So of course, I use Pythagoras Theory. Right, and from Pythagoras Theorem, you know that PR squared, that's hypotenuse squared, is equal to what? PQ squared plus QR squared, right? And then my PR squared is going to be, PQ is 10, so 10 squared plus 8 squared. So our PR squared is going to be 100 plus 64. 8 squared is 64, right? So I have PR squared is going to give me this and this is going to give me 164, right? So my PR is going to give me a square root of what? 164. And square root of 164 is going to give me 12.8 kilometers. But remember the question says you should leave the answer in the nearest meter. So converting this one to the nearest meters is going to give me 13 what? Nearest kilometers. So it means that the distance from P to R is 13 kilometers. Now the question went on to ask for the bearing of R from P. So the bearing is from R from P. So we are drawing from the north of P up to the R line, okay? This is the line that comes to R. If the question has demanded us to find the bearing of Q from P, then we would have ended at the P line. But this time it wants R. So finding the bearing, so here the bearing of R from P, you know it's going to give us this 90, right? We always start from the north, another 90, right? Making 180. So we just need this angle, theta. So the bearing of R from P is going to give us 180 plus what? Theta. That's going to be our bearing. So how do we find its theta? That's the problem. Now, you know that since this one is north-south and this also north-south, they are parallel. Once they are parallel, then this is alternating to that, right? So if this is theta, this is also what? Theta, right? And you also know that if this is 65, then this is going to be 25 because the whole quadrant is 90 degrees, right? So since this is 25 and this are also parallel, then if this is 25, then this is also going to be what? 25 degrees. Are you okay? Now, which means that if I find this whole angle and I subtract 25, I'm going to get this angle, the theta that I need. Are you getting that? Because this one, 25 plus theta, is going to give me the whole angle here. So let me rather find the whole angle here. Whatever I get, I subtract 25 to get what I want, theta, to add to the 180 to get my bearing. Are you okay? So, and this angle in question is the same angle here, this. Okay? So we can use trig to find this particular angle. Of course, this is my hypotenuse. The line facing the angle is my opposite, and this is my adjacent, right? We still use tan, right? Because we have the two given sides are O and A, which from SOHCAHTOA we use tan, right? So from this diagram, I can say that tan theta is opposite over adjacent. So it's going to be 10 on what? 8. So theta is going to be tan inverse. You know, whenever a trig ratios moves to the other side of the equal to sign, it takes its inverse form, right? So tan inverse of 10 over 8. And tan inverse of 10 over 8, it's actually going to give me 38.66 degrees. So 38.66 degrees. So it means theta is approximately equal to what? 39 degrees, right? Therefore, the bearing that I'm looking for, the bearing is what? 180 plus the theta, that's what? 39. And it's going to give me what? 219 degrees, right? Okay, so I think and believe that based on these two questions that we've solved, you'll be able to solve the questions that we will give to you. So, of course, the questions will be displayed on the screen or will be sent to you. So try and then solve them. And anytime you have a problem, of course, don't hesitate to call me, right? You already have my number. That's 0549 169 506. So thank you very much. If you have any problem, you can call me. Thank you. We'll meet next time.